Number 3, I know there's a bunch of ways to solve this. You could do it by hand using your slope formula. You could plug in points into your equations and see what works. Or anytime I see a chart, I'm going to plug it into Desmos. So I pull up Desmos, I go to here, I add a table, and I plug in 2x and 2y values. So we'll do 5 and 16.94, 10 and 21.89. And I just click this little button here to graph. And there's my answer almost immediately. It looks like it's going to be letter choice B here. Number 6, what are the values of x that satisfy the equation? Another way of asking for your solutions. Again, we could solve this by hand. We could plug these in to our equation to see if it works. Or anytime I see an x function, we pull up Desmos. So all I do is plug in my function, x squared minus 1. You want to do a parenthesis here. Whenever you're trying to divide by multiple things, if I just do divide, a lot of times it's just going to do my second character. So what I do is I put a parenthesis here, then I can divide by plural things, x minus 1, click over, and then equals -2. And when you see these vertical lines, these are always going to represent your x solutions. So it looks like we're going to be at -1, -2, -3 here, and let's go ahead and hide Desmos. -3 looks like it's just going to be A here. Number 11, a little circle review. We want to know how to find the center and radius of a standard form of a circle. This is standard form. We have an x term squared, a y term squared, and to keep it symmetrical, this is technically our radius squared. So if you want to find the radius, it's going to be that number off written by itself. We take the square root of it. So our radius is actually going to be 2 here. So we did want a radius of 2, so we know it's going to be A or B because they both have that 4. And then to get our center, just remember that we want to think of the opposite for when we have this x and y in parentheses. So if I see an x minus 5, I want to think x is 5. Y minus 7, I want to think 7. This would have been the opposite. This would have been -5 and -7, and we want positives. So A is just going to represent the standard form of a circle with a center of 5, 7, and a radius of 2. Number 12, remember your SOHCAHTOA rules. So helps remind us that our sine of an x is going to be equal to opposite over hypotenuse. Our CA reminds us that cosine of an angle x is going to be equal to our adjacent over hypotenuse. And finally, TOA reminds us that our tangent, we'll squeeze this in the bottom here, is equal to our opposite over our, maybe we'll do it this way, over our adjacent. So if I go up to my triangles here, we can kind of practice each of these. So just looking at this triangle here, if I said my angle was C, our opposite over hypotenuse, remember opposite's always the far one, so that would be 12 over 13. If I did cosine of C, it would be adjacent. So it'd be the one that's touching it that's not the hypotenuse. That would be 5 over 13. And finally, if I took tangent of C, that's going to be the opposite over our adjacent. So that's going to be 12 over 5. Also remember that with similar triangles, they tell us the ABC is similar to this bigger triangle. Your angles are equal. Sides are proportionate. So this is similar, or this is equivalent to this. This is equivalent to this. So whenever they ask for, in this case, cosine of E, I know that they're also asking for the cosine of B because they're equivalent. Remember your cosine rules, cosine of B is going to be adjacent to B, 12, divided by our hypotenuse, 13. So it looks like it's going to be B here. Number 14, again, of course, you can plug in your answers to see if they work. You can just solve for your x solutions, or just plug our functions into Desmos. So I start off, I say, okay, we got the square root of 4x, and that's going to be equal to x minus 3. Again, I zoom out and I see that I have one solution that looks like it's only going to be at positive 9. Immediately I know my answer is Roman numeral 2, or only B here. Number 15, finally a good one. This is going to be a standardized problem. You're going to see this practically every test you take. Remember, going into these more medium to hard problems, you want to be very categorical. When I see no solution, there's two types of problems that I could see above. I could either see a parabola, which is going to have a way to solve it, or I could see two linear equations. They tell us A is a constant, so I know these are two linear equations. How do we always solve these, right? You can do these on Desmos. The problem is sometimes it's free response, and sometimes for your slopes, you get really weird fractions like -14 over 15, and I think it can be a little bit harder to use your slider. So I just stick to always solving these by hand. Whenever you see two linear equations, no solution, get rid of your y-intercepts, and then put them both in slope-intercept form. The reason is because for two lines to have no solution, they have to be parallel, and parallel lines have equal slopes. So if we put them both in slope-intercept form, we can set our slopes equal. For this first one, I'm going to add 3x to the other side. That one's easy. Y is equal to 3x. For this next one, subtract the ax over. So 2y is equal to negative ax. Let's use a different color. And then when we divide both sides by 2, we get, and I like to keep the slope separate, you'll see, we get y is equal to negative a over 2x. Finally, we can set our slopes equal to each other. The first slope is going to be 3. My second slope is negative a over 2. And we just solve for a now. I'm going to multiply both sides by 2. And finally, we have 6 is equal to negative a. Divide both sides by a negative. Negative 6 is equal to a. So not too bad at all. That's how we're going to always want to solve these types of problems. Number 17. Anytime I see absolute values, I open up Desmos. At the keyboard at the bottom here, we're going to find our absolute value bars. I do 2x plus 1, finish the absolute value, is equal to 5. And I see my two solutions right here. Looks like it's going to be negative 3, positive 2. We'll write that down. X is going to be equal to negative 3, positive 2. And before I do close Desmos, look what it says. It says A and B are the two solutions. Well, this is A and B, or B and A, it shouldn't matter. And they want us to solve for the absolute value of A minus B. So we can try it either way. I just do it again in Desmos. We won't need that anymore. Absolute value of negative 3 minus 2. And I should get positive 5, or I could do it the other way just to make sure. 2 minus a negative 3, finish my absolute value, and I get 5 both ways. So it looks like it's just going to be 5 here. Number 18, another good one. I see Juan purchased this antique for a value of $200 at the time of purchase. At the time of purchase is another way of saying initial, so I know at my initial, we paid $200. Let's see how this progresses. I see each year the value is estimated to increase 10% over its value the previous year. So we'll do one quick iteration of this. So 1 year later, remember to increase by 10%. I can just multiply it by 1.1. And if we multiply that, we should get 220 here. So that's what it should be worth the next year. Let's see how far they want us to go. They say the estimated value of the antique in dollars 2 years after. Remember, we want to pause here. So whenever they say the area of something, they want you to find the value of it 2 years after. I pause, I find the value 2 years after myself before we continue reading. So 2 years, remember, we just want to multiply this by 1.1 again. And this time it's going to be a little bit different. It's not plus 20. You should get 242 if you do that multiplication. That's because we're not increasing 10% from 200. We're now increasing 10% from 220, which is a little bit more. So my value 2 years later is 242. But look, they also say 2 years after can be represented by the expression 200a. They love doing this on the SAT. They mention you solving for something, you can solve for it yourself, and then set it equal to their expression. Both of these represent the value of this antique 2 years later. In this equation, I just divide both sides by 200, and you should get for A is equal to 1.21. Not too bad for that one. Number 19, remember for any system of equations that doesn't have a variable, I'm throwing this straight in Desmos. Let's get rid of these. And I see 2x plus 3y is equal to 1200. I also see 3x plus 2y is equal to 1300. And I just zoom out, and remember, you're always looking for your intersection point. I see 300, 200, and on my problem, what that means is my x is equal to 300, and my y is equal to 200. Oops. And then let's slide this down so you can kind of see the rest of what they're asking. So before I even close out of Desmos, I see they don't want x or y. They want 5x plus 5y. So in my expression, let's go ahead and rearrange this. So 5x, which was 300, plus 5y, which was 200, is just going to get us 2500 for this one. That's exactly what I would type in. Finally, number 20, another good one and another good habit to create. So if you're doing this by hand, you're probably already fine. But like if you want to do the easy Desmos solution to every problem, anytime they use two random letters, you can just replace them with x and y. So if I pull Desmos up here, and let's kind of slide it down a little bit here, I would go into my expressions and I would type, instead of u plus t equals 5, I could do x plus y is equal to 5. For my second expression, u minus t, I could do x minus y is equal to 2. And I should see, if I zoom in enough here, an intersection point of 3.5, 1.5. So I can export this over here so I don't have to keep clicking on that point. So that's going to be my x and y value. Now, again, instead of closing Desmos, I just jump to the expression. They want to know what the value of this is. So I know that my x or my u is 3.5, my y or my t is 1.5. So I can just type this in. U minus t, 3.5 minus 1.5. And that's going to be times 3.5 to the second minus 1.5 to the second, and we get 20. So these problems really are that easy. Replace your two random letters with x and y, use Desmos, we're done with this worksheet. Here's the rest of the answers in case you were wondering.